All right, ladies and gentlemen, let us get going. So we're going to talk about surface area, prisms, and cylinders. I'm going to make this a lighter color, and here we go. All right, so same basic steps that we did before, except one minor change. So you're going to identify the figure, and then here's the minor change. You're going to identify what are they asking for. Is it going to be volume or surface area? Then you're going to use your notes to find the formula, unless you've memorized it, which would be better. Step 3, insert the values that you've been given from the figure into the formula, and then solve whatever they need. Usually it'll be for area or for surface area or for volume, unless for some reason you get a weird one like we had a couple of sections ago. But most of the time you're going to be looking for volume and surface area. So surface area, the sum of the areas of all the surfaces combined. So not just one of them, all of them. So that'll look something like this. They give you a box, and if you unfolded it and you got all the area of each individual side, that would turn into the surface area of the entire box. So you can see we've got top, we've got the back, the bottom, the front, the top, and then each side. So several things that you'd have to add together. So we're going to end up adding 1, 2, 3, 4, 5, 6 things together. So we're going to call those things faces, and then the area of each face. So we're going to do these in twos. So we're going to take the top and the bottom. So top, bottom. We're going to take those two. We're going to take the front and back. And then we're going to take each of the sides. So side 1, side 2. So we're going to add all those areas together to get the whole thing. So the sum of the top and bottom is going to be width, length times width, and then length times width. So we have the area of this section and the area of this section. Then we have length times width and length times width again, which would be the front and the back. So front and back. So there's the lengths, there's the widths. And then the last one would be each of the two sides. So we're going to take the height and the width in the blue over there. And we will add all three of those together. Now we've added together 2L plus 2L plus 2WH. And we can actually simplify that. We haven't done a whole lot of that so far, but you can actually divide pull the 2 out of each one of those and leave the 2 on the outside of some parentheses. So 2 length times width plus length times width times or plus width times height. Add all together, you get the formula. So here is that same formula. So the surface area of S is a rectangular prism with lengths L, widths W, heights H, is the sum of the areas of all the faces. So same thing we just did, sides or surface area, 2LW, 2LH, 2WH, or you can pull them out, length times width, length times height, all the way around. So identify regular prism. Are they asking for the surface area? Yes, here's the formula for surface area. And ta-da, there we go. Next thing we're going to have is the surface area of a cylinder. So this is still similar to what we had before. We're taking all the surfaces and we're going to add them all together. So in this case, we're going to have a circular top or circular base and top. So we call those the bases. They're congruent. And then if you unravel the circle, it actually ends up being a rectangle. Sorry, it kind of curves off over here, but it should be a rectangle. So how we would model that is we'd take the bases, the curved surfaces, and the height. And then circumference is going to be something else here. So the bases are 2 congruent circles. The curved surfaces are rectangles. So the height is the width of the rectangle, and the circumference is the length of. So the length from here, circumference is the length, the height is that. So when we'd add all those together, we'd end up getting our formula, which will look something like this. So the surface area of the cylinder equals the area of the two circular bases. So we know how to find the area, pi r squared. So 2 circles plus the area of the curved surface. And we just said that that would be the height times the circumference, which is pi r. Or sorry, 2 pi r is how you find the length. And we can put that all together into a beautiful little formula. Surface area is S. So this S, the surface area S of a cylinder with a height of h and a radius of r is the area of the two bases plus the area of the curved surface. So surface area equals, here's your formula, 2 pi r squared plus 2 pi r h. It's example time. Find the surface area of a regular prism. So we have to unravel the whole thing. We're going to first identify it is a rectangular prism, and they are asking for surface area. So I'd go straight into find the formula, write it down. Okay, now I need to identify which things I'm going to use for what. Which one's L, which one's W, which one's H. So in this case, we're going to use the long one for L. We're going to use the height is 4, and the width is 21. And you just insert 34 for the length, 21 for the width, and 4 for the height. Notice each value is used twice. And after you put all that into your calculator, you'll come up with that, or 1868. So the surface area of a rectangular prism is 1868 square centimeters. Again, you could write that as centimeters squared. All right, pause it, give it a shot. Okay, so same concept as before. First, you can say, it's a rectangular prism, and they're asking for the surface area. So you find your formula. You're going to have to identify which is going to be which. So I'm going to say this is my length. This is going to be my width. This is going to be my height. You'd punch all of those in to your formula. After you punch those all in, you should come out to 444 inches squared. Right, example 2. Find the surface area of a triangular prism. Okay, this isn't too much different other than the fact that now instead of having rectangles, now we have triangles as our bases. So that means we're going to have to divide those by 2. So find the area of each face. So in this case, we're going to use the bottom, which will be 20 by 3. So they did the bottom parts here. So they did this one first. So bottom, they're going to do the left side, 12 by 3. So they're doing this square down here. So 1, 2. We're going to do the right side, which is going to be 16 and 3. So that's this square. So they've worked their way around. 1, 2, 3. And then the value of two bases. So triangles, to find a triangle, you do 12 times 16. In order, because that would be, you don't take the hypotenuse, be careful. So here's the base height, because this is where the 90 degree is, so be careful. It's 12 times 16 divided by 2. Multiply that whole thing by 2, or you could just cancel those two out and leave it as 12 by 16. Both come out to the same answer, but this having the 1/2 in there would make more sense. So then you're going to add all of those together. 60 plus 36 plus 48 plus 192 equals 336. So it would be 336 square meters, or meters squared. All right, pause this one, give it a shot. Same as the steps before. Okay, so you do the same thing as they did in the last one. I'm going to take the bottom, which I'm going to do 5 and 7. I'm going to take the back part over here, which is going to be 3 by 7. Which is 21. And then the front section, so it's going to be 7 by 4. And then the last one, we'll take each of the sides. Now, where's the 90-degree angle? So it's going to be 1/2 3 times 4. And there's 2 of them, so we'd multiply it by 2. You could simplify this out a little bit, so you could go 3 times 4 over 2, and then put 2 out here. These would cancel, which would just leave 3 by 4, 3 times 4, which equals 12. So I'm going to add 35 plus 21 plus 28 plus 12 will come out equaling 96 feet squared. All right, example 3. Find the surface area of the cylinder round to the nearest tenth, because you're going to be dealing with pi here. So first you would say, okay, it's a cylinder, and we're looking for the surface area. So I grab that formula from my notes of surface area of a cylinder. 2 pi r squared, and then 2 pi r height, or h. Okay, my height's going to be 8. My radius is 2.5. Yes, that's the radius, not the diameter. Punch those numbers in there, and then it's just doing it in your calculator. Make sure when you punch it into your calculator, if you don't have a graphing calculator, that you do the squared first. Comes out to 169.9. So 169.9 square meters. All right, pause it, give it a shot. Okay, so it is a cylinder and it is round to the nearest tenth. So I'm going to put those into my formulas. So it's 2 pi r plus 2 pi r, pi r squared, and pi r h. Because this is my circumference, and this is my bases. So the circumference is for 2 pi r, multiply that by the height. Punch in my numbers here, so 2 pi, my radius is 8.2 squared, plus, looks like 2 pi r of 8.2, and times that by 21. Multiply that all out, should come out to approximately 1504.1 inches squared. All right, we're going to go really fast. The company packages its cereals by rectangular prisms with 2.5 inches by 7 inches by 12 inches, and is considering packing into a cylinder-shaped container having a 6-inch diameter with a height of about 7.5. What's the least amount of packaging? So I need to find the surface area. Okay, so the surface of the rectangular prism, top and bottom, front and back, and sides. Take my numbers from up here, 12, 7, 2.5, add them all together, comes out to this, but I'm not done yet. Okay, then I have to find the surface area of the cylinder. Okay, so earlier, my cylinder up here is 6 and 7.5. So I put, 3 and 7.5, because that was the diameter, not the radius. And that comes out to this, 169.9. I believe now we are still not quite done. So since 179.9 square inches is less than 263, the cylinder is going to use less packaging. All right, quickly try this one. I've only got a few seconds. So again, they're asking for which one has less packaging. So find the area of the surface area of the rectangle and the surface area of the cylinder, and compare them together. So this comes out to the rectangular prism requires less packaging because 78 is less than 88. So the rectangular prism comes out to 78, and this one comes out to 88. Good luck on the lesson.